Okay, so some of you all had some questions about the monohybrid worksheet, and I wanted to answer those by going over a few of them with you, but there's so few on that worksheet um, that I didn't want to do the whole thing for you. So I brought up this SpongeBob SquarePants worksheet that's very similar to it, and I was just going to go through a few with you to see if that helps at all. So, one of the first questions it's asking you is to identify the genotype. Okay, and remember the genotype are the genes present in an organism. Okay, so these big T's and little t's and letters are representing genes present in the organism. So, for example, this big T could represent the gene present for a tall individual. So it wants you to identify them as heterozygous and homozygous. And remember, hetero means different and homo means the same. So big T is going to be homozygous. So big T is homozygous because they're the same. Big B, little b is going to be heterozygous. Big D, homozygous again. Now we move on down. And now it's asking me to determine the phenotype for each genotype using the information provided by about SpongeBob. And it says yellow body color is dominant to blue. Now, the first thing that we need to remember here are the definitions for genotype and phenotype. Genotype being the genes present in an organism, and phenotype being the physical appearance of these genes. So, here we have big Y, and that's going to represent yellow because it's dominant. And remember, capital letters represent the dominant trait or the dominant allele. And uh, so that leaves blue to be these lowercase y's or a lowercase y. Big Y for yellow, little y for blue. So big Y is going to represent or is going to be seen as a yellow body color. While big Y is going to still be yellow because this big Y is going to dominate over this little y, and all you're going to see is yellow body color. Here we have little y, and those are both recessive alleles. So they're going to be seen as, so we're actually going to be able to see the recessive trait, which is blue. So remember that you have to have both recessive alleles present to be able to see a recessive trait. So it's going to be blue. Okay, here we have square shape is dominant to round. So that would be big S, or big S is going to represent the square shape, while the little s is going to represent round shape because the square shape is dominant and round shape is going to be recessive. So big S is going to represent square because we have both dominant here. So it's going to be seen as a square shape. While big S, little s It's also going to be seen as a square shape because it's going to, this big S is going to dominate over this little s. So we're going to have a square shape. And then here we have little s, little s. Okay, so these are both recessive alleles, and we're going to actually be able to see them as recessive alleles. So that's going to be round. So we're going to actually see that round shape because two recessive alleles are present. Okay, so this is asking you to do the same thing only backwards, okay? It's telling you, or let's read the directions first. It says, first, each phenotype gives a genotype that are possible for Patrick. So it's given us the phenotype. Now we need to determine the genotype. So a tall head, big T, is dominant to short, little t. So if we have tall, that's our phenotype. That's what we're seeing. What are the genes present in this organism? Or what could they be? And for tall, it could be two. It could either be big T, or big T, little t. Oops. For short, the same thing. Or for short, there's only one possible scenario since it's a recessive trait. And that genotype is little t, little t. Now, pink body color. Big P, pink body color, is dominant to yellow, little p. So for pink body color, we can have either big P, or big P, little p, oops, or little p, or yellow body color. Little p over here for yellow body color, because that's the only possible way. We have to have both recessive traits present to see that recessive allele. Okay, so now let's go down here and actually start the monohybrid crosses. The first thing that you want to do is you want to identify the parent's genotype, so which letters that they're carrying. And it says that SpongeBob SquarePants recently met Sponge Susie Roundpants at a dance. SpongeBob is heterozygous for his square shape, but Sponge Susie is round. Create a Punnett square to show the possibilities that would result if SpongeBob and Sponge Susie had children. Okay, so SpongeBob SquarePants is square, and it says right here he is heterozygous, and Sponge Susie is round. So we know that a heterozygous square shape, we read that up above, would be big S, little s, because it's heterozygous, so it's two different. He was square, that was a dominant trait. While Sponge Susie is round, she's representing, or she's showing a recessive trait. That's her phenotype. Her genotype would be little s, little s. So we cross them. And I actually made a mistake right here. And this should be two little s's. So we have big S, little s, big S, little s, little s, little s, little s, little s. So we look and it says list the possible genotypes and phenotypes for the children. Well, big S, little s, and little s would be the genotypes. And big S, little s is going to be a square shape because it has that dominant trait in it. It's going to dominate over the recessive trait. And here we have little s, and that's going to be round shape because that recessive allele, or those recessive alleles are going to show through, and that's going to be the phenotype. Okay, now it says what are the chances of the child with square shape? Okay, so if you look at this, you want to look and you want to see, I tell my students to look at this and think of it as 4 quarters and $1 if you have trouble with percentages. We know that 4 quarters and $1 you'd have 25 cents, 2 quarters 50 cents, 3 quarters 75 cents, and 4 quarters would be $1, 100%. Well, we would have 2 quarters here. So it's 2 out of 4. That would be square shape. That would be 25, 50, 50%. What are the chances of round shape? We have little s, 2 right here, 2 out of 4, 50%. And if it asks for a ratio is going to be, and it will say sometimes genotypic ratio. And phenotypic. I'm just going to put pheno right here. And so when we look for the genotypic ratio, we have big S, little s, to little s, little s, okay? So that's 2 to 2, or we run that down 1 to 1. So that means for every 1 big S, little s, we have 1 little s, little s. Now for phenotype, it's a little different because we're looking to see what these individuals look like. Well, we know that these two are going to be square shape, and we know that these two are going to be round shape. So it's 2 to 2. We run that down 1 to 1. So for every 1 round, for every 1 square, we see 1 round. Now that can differ because sometimes we could have big S, and big S, and little s, and that would give us different genotypic and phenotypic ratios. All right, let's do one more. Okay, so now it says Patrick met Patty at a dance. Both of them are heterozygous for their pink body color, which is dominant over yellow body color. Create a Punnett square to show the possibilities that would result if Patrick and Patty had children. Okay, so the first thing that we need to do is we need to figure out the parent's genotype. So it says Patrick met Patty at a dance. Okay, both of them are heterozygous for their pink body color. So they have pink body color. Whoops. And it's heterozygous. And we know the pink body color is dominant to yellow body color. Okay, so that would mean that they're both big P, little p, because they're heterozygous and they display a dominant trait. Well, they're heterozygous, so that tells us regardless. So then we cross them, and we're going to take from the top and the side, big P, big P. And then here we have big P, little p. We have big P, little p, and big P, or I'm sorry, little p, little p. I'll just put that down like that so you know those are little p's. Okay, so now it says list the genotypes and the possible phenotypes. So big P are the genotypes. big P, little p, little p, little p. So big P is going to be pink body color because it's dominant. Pink is dominant. Big P, little p is going to be also pink body color. And I'm just going to put, so hard to draw with this, pink. And little p is going to be yellow. Okay. So it says, what are the chances with a child with pink body color? And we look, and this one's going to be pink, this one's going to be pink, and this one's going to be pink. So that's going to be 3 out of 4, or 75%. And then we have, it says yellow body color. We have 1 yellow body color, because that's a recessive trait. We have to have both recessive alleles present to see that. That's 1 out of 4. That's 25%. Now, if we're going to do genotypic and phenotypic ratios, and I'm just going to put PR and GR for phenotypic and genotypic ratios. Phenotypic is what we're going to see. So we see 3 pinks to 1 yellow. So that's going to be a 3-to-1 ratio because we have 3 to 1. And then a genotypic ratio, we're going to look at the genotypes, and big P, little p, and little p. So we have one of these, we have big P, little p, we have 2 of these, and we have little p, one of those. So that's actually going to be a 1 to 2 to 1 ratio. For every 1 big P, we have 2 big P, little p's, and 1 little p. Okay. So I hope that helps. If you guys need any thing else, just let me know.